All right, you ready to keep going? All right, hope so. We just finished our last video with number 10. Now we're going to be working with number 11. Now, notice something a little bit different about this one. Our exponent is a b plus 1, but I'm still taking the log of both sides. Whenever my variable is an exponent, I need to do it with logs. Because what does that b plus 1 do? It now comes down in front, but it's the whole thing. Now from here, I've got a couple possibilities. Could I distribute this through? I could. However, I just think it'd be a little bit easier right now if we did this. So I have b plus 1 is less than or equal to the log of 7.31 over the log of 2. So if I calculate that, the log of 7.31 divided by the natural log of 2, whoops, sorry about that, I would get 2.8699. Then I'm going to subtract 1 from both sides. I get 1.8699. Alright, so give me a number less than 1.8699. A 1 you say, I like. 1 is definitely less than that. Let's plug in 1. 1 plus 1 is 2. 2 squared is 4. Is 4 less than 7.31? It sure is. This is a good answer. Alright. Log of 9, z minus 2 is greater than the log of 38. Oh, here we go. Z minus 2. That's the key right there. Once we pull that exponent down, we are home free. Divide by the log of 9. So z will equal, whoops, no it's not. It's not an equality, it's not an equation, it's an inequality. Z will be greater. There I go again. I'm thinking before I'm writing. Z minus 2 is greater than the log of 38 divided by the log of 9. Alright. So what's the log of 38 divided by the log of 9? Well, I'm glad you asked, because I can tell you that that answer is 1.6556. Add 2 to both sides, and I get 3.6556. Again, not equals, not equal. It's greater than. Let's see if it's true. Give me a number greater than 3.6. I like it. 4. 4 minus 2 is 2. 9 squared is 81. Is 81 bigger than 38? You betcha. We're good. It doesn't matter that you're an x squared, because we're still taking that exponent and going to bring it down. X squared log of 30 equals log of 50. Now that we brought it down, I can divide by log of 30. So I end up with this equation. X squared is going to equal the log of 50 divided by the log of 30. What I'm going to do, though, is I'm going to take the square root of it. Because that's how I calculated it originally. And I'm going to get an answer of 1.0725. Now, remember, if I am solving an equation where x squared equals a number, my answer could be plus or minus that. Because a positive 1 and a negative 1, if I square them, will both become a positive number. So is that about right? Let's see. If I just, a number close to that is 1. 1 squared is 1. 30 to the first power, is that close to 50? It's okay. This seems a reasonable answer, so we'll take it. If we don't know the exponent, we make it a log. So the x squared minus 3 comes down. And we have log of 5 equals log of 72. I'm going to divide both sides by the log of 5. So now I know that x squared minus 3 is the log of 72 divided by the log of 5. So the log of 72 divided by the log of 5 is approximately 2.6572. When we're going to do that, now I'm going to add 3 to both sides to make it 5.6572, and then take the square root. So the square root of that would give me 2.3785. Oh, well, what did I say? If we don't know the exponents, we take the log of both sides. My hesitation was that we have log on both sides. We have unknown exponents on both sides, which we haven't had before. That's okay. Let's do it, though. We can do it. I trust us. What does the exponents do? They come down in front. Now, what do you think? I think the easiest thing to do is to distribute all this stuff through. Multiply the log of 2 by n, and multiply the log of 2 by 1. Okay, same thing with this side. 2n log of 5 minus 1 times log of 5. I'm thinking it looks a little long and crazy. Why are we doing that? Well, because we have these expressions on both sides of the equation, let's multiply them out. On one side of the equation, just put the stuff with the n's. So this n log of 2 is already here. So now I want to take this one and bring it over to the other side. So I'm going to subtract 2n log of 5. Alright. Now this negative log of 5 is already here. I need to put this one and move it to the other side. So instead of a plus log of 2, it'll be a minus log of 2. A little crazy, but we're actually almost done. I can factor out an n. If I take an n out, I'm left with 2 log of 5 and I have this side. Alright, then what do I do? Well, here's my n. I got to solve for n, right? I'm dividing both sides by log of 2 minus 2 log of 5. So was the algebra for this one a little bit more intensive? Sure it was. But right now my answer is going to be the expression that solves this. This technically is my number, but that's an ugly number. I have no idea what that number is even close to. Well, if I put it into my handy dandy calculator, I'm going to get 0.9117. Alright, so that was kind of the craziest equation we had, but the idea is if you want to get rid of exponents, if you have exponents that are unknowns, logs will help you solve those equations. Now this one's a real quick one. It's a really nice and easy one. How in the world would I calculate the log base 3 of 13? How do I know what this equals? Well, how were we doing that? The log of 3 to the x equals the log of 13. X comes down in front. Divide by log of 3. Now I don't want to actually calculate it. I want you to see what's happening here. It's the log of 13 divided by the log of 3. Here's 3. Here's 3. Here's 3. 3. 3. Okay. Here's 13. So I want you to look from this one to this one. How did I calculate this without using a log base 3? See what it changed into? So here's your change of base formula, okay? You do the log of b divided by the log of a. That way you can actually calculate it on your calculator, because your calculator most likely does not have a spot to put log base 3. Some calculators do. TI Inspires do have that ability, but most do not. So how can I use this change of base formula to calculate log base 7 of 12? This is what I put on my calculator. And I just figure out the answer, which, coincidentally enough, to 4 decimal places is 1.2770. Lots of 1s, 2s, and 7s, don't you think, for my birthday? Okay, this is the log of 32 divided by the log of 8. And let's see, what is that? Log 32 divided by log of 8. Oh. One and 2/3. Kind of makes sense, doesn't it? 8 to what power is 32? Well, that's how we do it. Oh, I threw you a curveball here. Log of 7 over log of 12. My birthday again, but just reverse ordered. Log of 7 divided by log of 12. 0.7831. And the log of the square root of 8 over the log of 7 equals about what? Let's see, log of the square root of 8. Oops. Okay, divided by log of 7. Five, 2, 4, 6. All right, change of base formula. I'm going to leave you with one last problem, and we're going to use logs to figure this out. 1,000 bacteria in a culture doubles every hour. Here's the formula. Now, we figured out that formula before, earlier in the chapter. 1,000 to start with, doubling, so there's the 2. We want to know when it gets to 50,000. Now we're solving this equation. Before I would tell you, I'd give you a time. and you had to figure out how many were there after a certain number of hours. Now I'm telling you how long it's going to be till 50,000 bacteria are alive in there. We solve this equation. Well, first thing, let's divide by 1,000. Take off 3 zeros, so 50 is 2 to the t. Then how do I solve that? Well, again, unknown's a variable. Or the unknown's an exponent. So the t can come out in front. And divide both sides by the log of 2. Alright, now we'll flip it around. T is about, let's see, log of 50 divided by log of 2. It's about 5.6. So in about 5.6 hours, my 1,000 bacteria will increase to 50,000 bacteria. So they get up there pretty quickly, don't they? All right, there you go, common logarithms. So if you have any questions, please let me know. Otherwise, great job, and I will see you next week. So have a good one. Bye.